Alright, let's try to solve the next set of problem, which is problem 515 of your white textbook. The statement of the problem reads: the wall shear stress tau W in a boundary layer is assumed to be a function of stream velocity u to be precise capital U, boundary layer thickness delta, local turbulence velocity small u, small u prime, density rho, and local pressure gradient dp by dx. Using rho capital U delta as repeating variables, rewrite this relationship as a dimensionless function. So to start off, basic problem of the solution. The proposed function is tau W, which is shear stress, is equals to a function of capital U, which is the stream velocity, boundary layer thickness delta, local turbulence velocity u prime, density rho, and pressure gradient dp by dx. We'll be solving this problem using Pi theorem. So step 1 of the problem, number of variables involved in the problem, and those are tau w, u, delta, small u prime, rho, and dp by dx. So hence, once we count all these, we have an n value of total 6. Step 2, dimensions for each of these variables. Let's do it step by step. So tau w, which is nothing but shear stress, and shear stress is given by force upon area as we've encountered in previous problems. The dimension of force is given as m l t power minus 2, and dimension of area is given as L square. So this would come out to be m L power minus 1 t power minus 2. U is velocity, which is nothing but length over time. That is given as L over T, which is equals to LT power minus 1. Delta indicates thickness, and thickness is measured in terms of length. So it has a basic dimension as L. U prime is, capital U was stream velocity and U prime is turbulent velocity. So it is also represented as velocity, which is nothing but length divided by time. Dimensionally it is L over T, which is nothing but L T power minus 1. Rho indicates density, and density is mass upon volume. Mass is indicated by dimension m, and volume is indicated by L cube. So this is nothing but m L power minus 3. And last but not the least, dP by dx. This can be written as change in pressure delta P by change in length delta x. So that would be delta P over delta L, because change in length is measured as L, which is nothing but pressure over length. And pressure dimensionally is represented as m L power minus 1 T power minus 2, which is pressure as force over area, whole divided by L that gives us finally where change in length is divided by L. So the total thing would come out to be m L power minus 2 T power minus 2. So we have got the dimensions of each of the variable, which is our step 2. So let's proceed with uh, adjusting them into a table format, which is tau w u delta small u prime rho dp by dx. This will be m L power minus 1 T power minus 2 L T power minus 1 L again L T power minus 1 m L power minus 3 and finally m L power minus 2 T power minus 2. Let's proceed to start by in the next step of Pi theorem, which is step 3 of Pi theorem. Number of dimensions used. So if you observe, that is from the above table, you will see the number of dimensions that have been used are m, L and T. So therefore value of j, which is the number of dimensions, would be 3. We can find three variables which do not form dimensionless groups. For example, those three can be tau w u delta or u delta rho or u delta dp by dx. So j would be 3. Step 4 of the problem, or step 4 of the pi group. Select those repeating variables and which form the parameters or the dimensionless groups. So select u delta rho as stated in the problem statement, or j is equals to 3 parameters. Step 5 of the problem. Number of pi groups would be n minus j, which is n is in the step 1 we have counted as 6, and j we have found it on step 3 as 3. The total would be 3 pi groups. First, dimensionless group would be pi 1. So that would be rho u delta plus tau w. So the way we did it in the previous problem, we'll do it the same manner. Pi 1 would be a dimensionless group, would be equals to rho raised to the power of a, u raised to the power of b, delta raised to the power of c, and tau w raised to the power of 1. As we know, but pi 1 is dimensionless, that implies rho to the power of a, u to the power of b, delta to the power of c, tau w would be equals to, your pi 1 is a dimensionless part, so that can be represented in the basic dimensions mlt as m raised to 0, l raised to 0, t raised to 0. If we did have uh, another dimensional value as theta, we would take that also onto our right hand side and make it theta raised to the power of 0 and call it as a dimensionless group. And so that helps us while we are equating the bases and the powers as we proceed. So now, as we have done it in the previous problem, let's substitute the individual dimensions of individual variables. So that would be m l power minus 3 raised to power of a, l t power minus 1 raised to the power of b, l raised to the power of c, m l power minus 1 t power minus 2 is equals to m0 L0 t0. So now let's bring up the powers, bases and powers onto one side. So m would be a plus 1 and L would be minus 3a plus b plus c minus 1 and t would be minus b minus 2 is equals to m0 L0 T0. Now let's try to equate the bases and try to solve them. So a plus 1 is equals to 0, minus 3a plus b plus c minus 1 is equals to 0, minus b minus 2 is equals to 0. From this we can get a is equals to minus 1 and b is equals to minus 2. If we substitute a and b into this equation, into the middle equation, which is, we get it as minus 3 times minus 1 minus 2 plus c minus 1 is equals to 0, which implies c would be equals to 0. Now we have the values of a, b and c. We just got to substitute that into the pi group that we have created, which is pi1 group. So let's do that, which implies pi1 would be, when we put them, rho to the power of a, which is rho minus 1, u to the power of b, u raised to minus 2, delta to the power of c, which is 0, and tau w. That implies our first pi group would be in the format of tau w divided by rho u square is equals to constant. Second dimensionless group is pi2, that would have rho u delta. One thing that we have to remember is rho u delta have to be the repeating variables as per the problem statement. So these do not change. The fourth variable is changing. Previously we had shear stress that was brought in. Now we are bringing the turbulent velocity u, small u prime. So that implies pi2 would be equals to rho to the power of a, u to the power of b, delta to the power of c, and u prime to the power of 1. But we do know pi2 is dimensionless. Which indicates pi2 should be also represented in terms of mlt, but since it is dimensionless, or it is a constant, all the powers of individual dimensions should be risen to 0, which implies rho to the power of a, u to the power of b, delta to the power of c, u prime is equals to m raised to 0, l raised to 0, t raised to 0. As we have done in the first dimensionless group, we do the same step. We bring in the dimensions of individual variables rho, u and delta and u prime, and we substitute them. So rho would be m l power minus 3 whole raised to the power of a. U would be l t power minus 1 whole raised to the power of b. Delta would be l raised to the power of c. U prime is again a velocity, which would be represented as l t power minus 1, and this is equals to the right hand side, which is a dimensionless group or a dimensionless number, m power 0, l power 0, t power 0. Now let's bring up the bases and the powers onto one side. So the first thing would be, this implies m to the power of a, l to the power of minus 3a plus b plus c plus 1, and t raised to minus b plus c minus 1 is equals to m power 0, l power 0, t power 0. So when you have written like this, then you have to equate them. So here, if you look at them, it would be a is equals to 0 as the first equation, minus 3a plus b plus c plus 1 is equals to 0, and the second equation and the third equation, which would be minus b plus c plus minus 1 is equals to 0. Since we have a is equals to 0, if we can substitute that over here, we get b plus c plus 1 is equals to 0, and this is minus b plus c minus 1 is equals to 0. If we take these two equations and try to solve them, let me make a quick confirmation that okay, m per a, l per minus 3a plus b plus c plus 1, and t to the power of minus b oh sorry, I made a mistake over here. This should be t to the power of there is no c over here, because you don't see C part in uh, T, so that would be just minus B minus 1, and this again we have to change over here. This would be minus B minus 1 is equals to 0. So from this we get B is equals to minus 1. If you substitute this value into the second equation, you would get minus 1 plus C plus 1 is equals to 0, which implies C is equals to 0. Now we have got the values of A, B and C. We just got to substitute them in the second dimensionless group that you have created. So that would be pi 2 is equals to rho to the power of A, which is 0, u to the power of B, which is minus 1, delta to the power of C, which is 0, and u prime to the power of 1, which is like that. So this particular statement or group can be rewritten as pi 2 is equals to u prime upon u is equals to constant. And this is our second dimensionless group that has been created. Let's proceed with the next group, because we have three dimensionless group as per the problem when we have started the pi method. We found n minus j was 3, so this is the third one. Third dimensionless group this would be pi 3. Again we'll have a common variables rho, u, delta plus dp by dx. So we'll write it as, this implies pi 3 would be equals to rho to the power of A, u to the power of B, delta to the power of C, dp by dx whole raised to the power of 1. But we do know pi 3 is dimensionless. Again rearranging, rho A, ub, delta to the power of C, dp by dx is equals to m raised to 0, l raised to 0, t raised to 0. M l power minus 3 whole raised to the power of A, L t power minus 1 whole raised to the power of B, L whole raised to the power of C, dp by dx would be m l power minus 2 t power minus 2 whole raised to the power of 1 is equals to our right hand side, m power 0, l power 0, t power 0. Rearranging, we have m a plus 1 l minus 3a plus b plus c minus 2 t whole raised to the power of minus b minus 2 is equals to m raised to 0, l raised to 0, t raised to 0. So from this, when we are equating, we get a plus 1 is equals to 0 minus 3a plus b plus c minus 2 is equals to 0 minus b minus 2 is equals to 0, which implies a is equals to minus 1, b will be equals to minus 2. Substituting these two in the second equation, we get minus 3 times minus 1 minus 2 plus c minus 2 is equals to 0. So that will give c as 1, which implies pi 3 has, since we have all three powers, we can write pi 3 as rho to the power of a, which is minus 1, u to the power of p, which is minus 2, delta to the power of c, which is 1, dp by dx whole raised to the power of 1. And when we rearrange this, we get pi 3 is equals to delta dp whole divided by dp by dx. So dx goes to the denominator, u square is equals to constant. And we can, since this is a repeating thing, and from the problem statement it has been given to us that the shear stress is dependent on the remaining variables of the will be, I mean, shear stress would be equals to a function of the remaining variables. So as per the groups that we have done, we have we have repeated the three variables rho, u and delta, but we started off our first group using the shear stress. So let's put that as on the left hand side. So pi 1 is a function of the remaining two groups, pi 2 and pi 3. This implies we have tau w rho u square is equals to function of u prime over u comma delta dp over dx rho u square. This is the final form or the dimensionless group of this problem. Hope you have understood this problem. If you do have questions, you are free to ask me either by emailing me, or I'll be available on Microsoft Teams. So yeah, my email ID, you have already got it through your announcement notifications. So I would still repeat my email address, which is S as in Sam, L as in Lucy, A as in Apple, N as in Nancy, K as in King, A as in Apple at uwm.edu, which is slanka at uwm.edu. You're free to ask questions anytime. Thank you.